Okay, here we are. And let's begin. Okay. Hey everybody, welcome to another Lakehouse Lunch. This is a part of a series of the data from the Data Lakehouse Hub, and we'll talk more about what the Data Lakehouse Hub is in a moment. But today we'll be covering what is Apache Iceberg REST catalog. And my name is Alex Merced. I'm a senior technical evangelist for Dremio. Okay, so let's kind of move on here. And again, the Data Lakehouse Hub is basically a Data Lakehouse community. It includes this series of events along with a Slack community and a website, thedataLakehouseHub.com, where there's articles about the Data Lakehouse, again, the Slack channel, so that way you can meet with other people interested in the Data Lakehouse topic. I speak at a lot of events all across the country, so oftentimes I will list the events that I'm speaking at these different meetup channels that are inside that Slack community. So you can join the Slack community, join the meetup channel for your particular area, and find out when I'm in the area. But basically, if you're into data lakehouses, you can join this community by scanning the QR code. Also, we have a meetup group, the North American Open Data Lakehouse Linkups, where we generally list these events. So if you want to find out about these events, you can scan that QR code there. And again, all this will be recorded and posted on YouTube on the Data Lakehouse Hub YouTube channel within 24 hours of this session. And if anyone who's watching is interested in speaking at a future Data Lakehouse lunch, you can just email speaker@datalakehouseHub.com and we can see where a good time will be. But with no further ado, let's get into our featured presentation, talking about the Iceberg REST catalog. The idea here is that the REST catalog solves a particular problem, which is interoperability of your Lakehouse catalog when it comes to table operations, allowing different tools to be able to read, write, and manage your individual Iceberg tables. My name is Alex Merced. I'm a senior technical evangelist at Dremio. A little bit about me. I have spoken at a lot of different events, such as Data Council, Data Day Texas, many more. I've written a lot on data and on web development. I just really love technology as a whole. I'm also one of the co-authors of Apache Iceberg, the Definitive Guide. And if you haven't picked up a copy of Apache Iceberg, the Definitive Guide, you can get a free copy, a free PDF, by scanning this QR code here, which will allow you to go get a free copy of the book, which covers a wide variety of topics regarding running Apache Iceberg lakehouses. We are also running an Apache Iceberg crash course currently. We have 2 sessions to still go on live left. But all the sessions are available on demand. So basically, if you register, you get access to the on-demand sessions of this 10-session course that covers sort of what is Apache Iceberg, gets hands-on with Apache Iceberg, talks about catalogs, goes real in depth about all these different topics. And I think this will be the final sort of bit, but I'm also the host of several different podcasts, which you can find on Spotify and iTunes. You can find links to all these podcasts over there at alexmerced.com/data, where you can find all my links to everywhere I put out content on data. But with that, let's talk about what is a data lakehouse. Because again, the point of this conversation is to talk about what is the REST catalog. But to understand what the REST catalog is, we need to understand what Iceberg is. And to understand what Iceberg is, we need to know what a table format is. And table formats make sense in the context of a data lakehouse. So we need to know what a data lakehouse is. So let's build those layers so that way when we get to what REST catalog is, it's all nice and clear for everyone who's watching. But essentially, to kind of understand a data lakehouse, we need to know what came before. And generally what we've done as far as data processing up till now is we use 2 types of systems: databases and data warehouses. Okay, and the beauty of these systems is that they're complete software packages that do all the things for us. They figure out how we're going to store the data. They figure out how do we recognize which portions of that stored data are table 1 and table 2, so a table format. And they maintain a catalog of those tables, so that way I'm able to kind of see, hey, here's a listing of tables that are available in my system. And they do data processing, so I can write an SQL query, which gets parsed, turned into an execution plan, and then eventually execute it. Now, these systems are super useful and super great, and typically we use databases when it comes to transactional processing, storing the data oftentimes in a more row-based format, and data warehouses oftentimes more for analytical purposes, oftentimes storing the data in a columnar format. Now, the catch is that these systems are vertically integrated, meaning basically it's all one big system. So that means how each of these layers work is really unique to that system and not necessarily exposed. So in that case, if I want to use two different data warehouses, well, I'm probably going to have to make a copy of the data in both. This creates some engineering challenges because oftentimes, especially with the scale of data nowadays, we'll have different teams using different tools. But oftentimes we need to unite the data from those teams for a lot of our end use cases to build some of our, especially 360 type insights into our organizations. And now we have to move data around. This means more ETL pipelines. This means more costs of storage, egress fees, and then just the complication and the time delay of having to do all that. So it hurts our data story. So ideally what would happen is we'd be able to kind of work with the data sort of in one place across all our tools and teams. Only if there was sort of a place where, data was just sort of openly accessible. And there is such a place. We've always had this paradigm of a data lake, the idea of treating a storage layer, which is typically an object storage layer, originally like Hadoop clusters, but idea of a place where I can store files, and I can store my structured and unstructured data in that storage layer. So unstructured data like MP3s and videos and text files, and structured data like CSV, JSON, Parquet files. And then I could use a compute tool like a Dremio or AWS Athena to run SQL queries against that. But that had its limitations, as oftentimes was read-only. Basically, files don't really provide enough context to really have the same kind of guarantees and functionality as a data warehouse. So this wasn't necessarily a complete solution to eliminating that whole sort of data silo, data unification type goal. So how do we kind of get to the next step? Well, we add in those layers that are missing. Okay, so we have our storage layer, so that problem's been solved. We have our compute layers. But what if we add in a table format? So that way we can treat a bundle of files as a single table. Okay, what if we add in a catalog so that way we know which tables exist in the system? So that way when we interact with our data lake, we're no longer interacting with it as a storage system with a bunch of files. We're interacting it like a data warehouse system made up of tables, thus turning our data lake into a data warehouse, aka a data lake house. So Apache Iceberg is one of these table formats that enables this sort of data lake house paradigm. And what Apache Iceberg does is that it breaks up the way you track those files into sort of several layers of metadata. And then those tables, that metadata, is then tracked or cataloged by a catalog mechanism, which could be one of several things. Could be like a Nessie catalog, AWS Glue, REST catalog will be a big topic coming up, JDBC, there's all these catalogs. And what they do is they operate as a directory, saying, hey, here's table 1. For table 1, here's the location on your storage for that metadata. So very much like a phone book for your tables. And every tool can use the same phone book, the same catalog, and always find the same address for where that metadata is located, allowing there to be a consistent view of the data. So no matter which tool, if I ran a query with Dremio, ran a query with Spark, ran a query with Flink, all of them are going to access the same version of the table. Now when they access that metadata, the top layer of the metadata is the metadata.json, which defines like the schema, the partitioning scheme, maintains the history of snapshots. So you have all these listing of files. And typically every time the table changes, you create a new metadata.json. Everything in Iceberg is immutable. So you never update a file, you always add new files. So as the data changes, new metadata.jsons are being added, and it's the catalog who's responsible for always referring to the correct one. That way we make sure that all queries coming in are always looking at the correct version of the table. But then that metadata.json can then reference the snapshot, which is made up of a file called a manifest list, which we can now begin looking at the file metadata to begin doing file skipping, determining which files we don't have to scan. And then basically the manifest list usually has the list of manifests, which are groups of files, and the individual manifests are the actual list of individual files, both with metadata for file skipping. So using the data among these two layers you can then determine which files do you need to scan to accomplish your query for that particular job. And then you go scan those data files in storage. And again, most of this is all done by the engine. So using the Apache Iceberg libraries, like the Java libraries, the Python libraries, tools are able to build this functionality in, so that way you can read and write Iceberg tables. So this is how it mechanically works, but oftentimes when you're interacting with it, it's just like interacting with any other database system. You write SQL to add data, to query data, to create tables, and so forth. Okay, and that's essentially like really the real goal, to really make it where your data lake house or your data lake is treated like a data warehouse system, and the interaction is the same. The SQL experience is the same. But again, that catalog is a central point of consistency. That's what makes the data portable, because I just take that catalog from tool to tool. Okay, it allows all my tools that I'm going to query the data with, they need to communicate with the catalog so they can discover where my tables are in my storage. Okay, they create, so that way I'm not looking at a listing of files, I'm instead looking at a listing of tables in the same way I would interact with in a database or data warehouse. Okay, cool. So that's essentially what a catalog does, but let's take a look at how that mechanically works. Typically, really all the catalog does is that an engine like Dremio, like Snowflake, like others, would make a request to the catalog, and the catalog returns the location of the current metadata.json. That's its job. But how does it do that? It depends. There's generally two categories of catalogs. The first category, the file system catalog, is generally not recommended for production. This is oftentimes in the documentation referred to as Hadoop catalog, because it was originally designed for working with Hadoop systems, but it works with any file system. And essentially what they do here is that since there is no service, there's no server, catalog server, you do rely on a file that does get updated called version hint.txt, and that's generally the problem. So what's going to happen is that this version hint.txt file contains the name of the current metadata.json. So that means after every transaction, that file has to be updated. The problem happens is that not all file systems have the same update guarantees. So in that case, working with certain file systems, when you update that version hint.txt, there's a chance if you have concurrent writing going on, you might have inconsistency with inconsistent updates. So typically, this is great for like evaluating Iceberg and trying it out. It's pretty easy to use because it just uses your file system, but not recommended necessarily for production. Once you start going into production with Iceberg, you want to have an actual service as a catalog, where there's actually like a server that usually has some sort of backing database where it tracks all its references. And basically, when I make a request to the catalog, it's going to go retrieve the right reference from the database or the backing store and give that back to me. Because that backing store is probably going to have locking mechanisms to help provide us the guarantees that we need when you're updating the table. So you're going to want one of these catalogs. There's several different options, as you can see here. But what's happened is that there was problems, and this is the reason why eventually, as catalogs kept expanding and expanding, we had to move into this REST catalog story. So before we introduce REST catalog, let's talk about what went wrong. So originally, the way catalogs were done is that most of the logic was done on the client. So again, there's server and client. So server would be the catalog server that you deploy, and then your users would access that server using a client. So the code that would determine how to work with that catalog was oftentimes written on the client side. Okay, not on the server side. So this created a problem where basically you needed to create a custom implementation for each catalog of a client. So that wasn't so bad in the beginning, because in the beginning you just had Java. Okay, basically everything was done with Java for Iceberg. So basically you wrote one class for that particular catalog, and that catalog could now work in the Java ecosystem. But Iceberg expanded into other languages, Python, Rust, Go, and they can't just inherit what was done in Java. So in that case, for each catalog, you would have to re-implement all that logic into a new client class for each language. And because the client is something that's controlled by the user, not the server, you'd have to hope that the user, when they're configuring like their Spark session, that they're using the right version of that client. Okay, so they might be using, they might have one catalog server version and then a different client version, and things just don't work right. So you have this whole versioning issue. And three, when you're talking about managed services, so think of like an Upsolver or a Dremio, where basically everything is kind of abstracted away as far as setting up these connections. You have to hope that they create a connector for each catalog, since each catalog has a separate implementation. So you might have a Iceberg catalog, but you may not be able to use every single tool because your catalog may not connect to all tools. So basically the idea was, how do you solve all these problems? And the solution was the REST catalog. So now what happens is that you remove much of the logic over to the catalog. So now the catalog server has a lot of the details for what the actual operations are what operations are happening. And instead, the client is essentially a dummy client. The client really only has a certain list of REST API calls that it makes on this based on the operations it's trying to do. Like it's trying to read a table, write a table, retrieve a list of tables, whatever the operations they're going to do, and it'll just make the right API call to a set standard of API endpoints, and then the catalog server then implements the logic. So in that case, the same client can be used for multiple catalogs. So now instead of every catalog implementing its own client, everyone just uses the Iceberg REST client. So long as a tool supports the Iceberg REST client, any catalog can now be accessed. So this makes it where now all catalogs can be accessed by all tools. You only have to create one client per language. Okay, so basically Java, Iceberg REST, basically Java, Python, Rust, Go, and then you're good to go. All those catalogs become useful. And the versioning becomes less of an issue because it's basically each spec is versioned, and long as that, your version of the clients has a matching, supports the spec that your catalog is using, it can connect to it just fine. And then any changes really happen on the server side, like the way the catalog evolves is on the server, but they're still always going to use those same endpoints. So as the catalog evolves, the client doesn't necessarily have to change at all. So you're not really worried about that versioning side of things either, because all the changes are really happening server side. So by doing that shift, you make it a lot easier for people who are using Iceberg to be able to take the catalog that they want to use and use it everywhere. And this really kind of makes interop much easier in Iceberg, making it much easier to adopt Iceberg, because you don't have to spend so much time thinking about, hey, which catalog am I using? And finding out that you're locked out of a tool because you chose X catalog. Now there's several different tools that support REST catalogs. So here's like a listing of showing the logos of tools that you can actually connect to a REST catalog and read tables from, or write tables to, that support REST catalog, including Dremio, Snowflake, Flink, Spark, etc. And then here are catalogs that support REST catalog, which includes Nessie. So Project Nessie, which is a special catalog that provides Git-like versioning for Iceberg tables. There's Gravitino. There's Unity catalog and a Polaris catalog, which is now an incubating Apache project, so Apache Polaris, which provides some very interesting features as far as being able to actually have multiple catalogs within a catalog and being able to connect to other external catalogs, which are pretty cool. Now, one thing I do like to point out is that the REST catalog spec is just a listing of different API endpoints for different operations. Just because a server implements some of those endpoints doesn't mean they have to implement all of those endpoints. I'm going to call out the example of Unity catalog here. So Unity catalog was originally really designed for Delta Lake tables, but it has a feature called Uniform where it creates an Iceberg copy of the metadata for those Delta Lake tables. So the REST support here is really just on the read side. So if I tried to do a write operation against a Unity catalog, it would fail because it doesn't implement those particular endpoints, because it wasn't meant for you to write to those tables. Okay? Because again, it was built for natively working in Delta Lake. So the reason why that's important is that when you're evaluating catalogs, anything that supports REST catalog should be able to connect to all of your favorite tools, but it still doesn't guarantee that you necessarily have the full set of functionality of that REST spec unless that catalog has implemented the full REST spec. So you do want to do a lookup and saying, hey, if I adopt this catalog, do I have the ability to read and write to those Iceberg tables? Okay, so and depending on your particular use case. So if you're looking to read and write to Iceberg, then you're going to be better off using Nessie, Gravitino, Polaris. But if you're a Databricks shop and you're mainly working with Delta Lake tables and you want to read certain tables with an Iceberg only tool, then that's where like that REST connection to Unity catalog becomes really useful. So again, it depends on your particular use case, but the idea is to give you context and the kind of questions you should ask when architecting your Iceberg Lakehouse and the catalog you use for your Iceberg Lakehouse. So that hopefully clarifies like what is the Iceberg REST catalog. Now, the next step is really kind of get hands-on with like Iceberg and different catalogs and whatnot. And the tutorials that I have here, represented by these QR codes, will get you hands-on with Dremio, Iceberg, the Nessie catalog, and you can do it all from your laptop using Docker Compose. So the simplest tutorials all the way on the left, but all of these tutorials will get you hands-on, see the what a potential setup could look like, and what that architecture and that delivery from ingest to BI dashboard could look like. So in these 3 tutorials, what we're doing is we're ingesting from a source system like Postgres, SQL Server, or MongoDB, ingesting to Iceberg, and then building a dashboard off of it. So you can see that sort of that full workflow. All of these are off the Dremio blog, so I highly recommend working through these. They definitely give you a lot more insight and sort of like how this kind of architecture could look like. Again, this particular webinar was put together by the Data Lakehouse Hub. You can join the Data Lakehouse Hub Slack by scanning this QR code here. And then again, I speak at a lot of events, and you can follow the events that I'm speaking at, whether they're virtual or in person, by scanning this QR code here to subscribe to this calendar of events, where me and my counterpart at Dremio, Andrew Madsen, post the events that we speak at. But with that, thank you all for attending this session. I'll open it up to any questions. So if anyone has any questions, feel free to ask. Otherwise, we have gone over the content. Okay, so it looks like I don't see any questions, so I'm going to assume that we're good. But with that, I hope to see you all at the next Lakehouse Lunch. Again, if you subscribe to the meetup group, you will not miss. Oh, someone just joined. Oh, hello, Catherine. Oh, we're just wrapping up the presentation, but I don't know if you had any questions before we wrap up.
No, thank you.
Well, okay. Again, the presentation will be posted up on YouTube. I will probably try to post it up on YouTube pretty much right after I'm done here, so I will do that right away, and that'll be available on the Data Lakehouse Hub YouTube channel. So just look up Data Lakehouse Hub on YouTube, and you'll be able to watch this presentation there. And again, thank you everyone for attending. Have a great day.